Hi, today I'm going to explain what a voltage divider is, what it's comprised of, and some of the practical uses of a voltage divider in a circuit. A voltage divider is simply a series of two resistors that lower the voltage from a higher voltage to a lower voltage. So you'll have one resistor attached to your source, then that resistor will go to where you want the voltage to output. So let's say you have 12 volts and you want to turn it into 3. You'll put a resistor between the 12 volts and where you want the 3 volts to be. Then you're going to put another resistor between where you want 3 volts to be and ground. So the whole idea is you're going to be sending 12 volts over through a resistor to where you want your lower voltage to be, and then you're going to have a lower resistance resistor between where you want the power output to be and ground. So just to make this make a little sense, let me just show you how this works in a real world circuit. So over here, we want 3 volts on the enable pin of this backlight chip. So this backlight chip will turn on when it has 3 volts going to the enable pin. That's what it's spec'd for, 2.5 to 3 volts to the enable pin. The problem is that, as I explained in another video about transistors, this is a circuit that runs off of 12 volts. So the backlight circuit is responsible for taking 12 volts and turning it higher. Now, this machine's pretty smart. It already has a transistor over here that's going to block 12 volts from going through to the boost circuit unless this LCD backlight enable signal is here. So the way this works, if you watch my transistor video, you'd have an idea how this works, and you should have watched that before you watch this one. You have LCD backlight enable going here. Now, the way this works is when LCD backlight enable goes here, this transistor will open and send 12 volts through the backlight circuit, and you'll get the backlight to go on. But that's the problem, is that that's 12 volts. The enable pin runs off of 3 volts. So we already have a system in place here where when an LCD backlight enable signal comes through, it turns on the backlight circuit, right? We already have that, but that is running off of 12 volts because it's taking the 12 volt rail from the machine and it's sending that 12 volt rail through to the backlight boost circuit where it's then going to wind up as a boosted backlight voltage that's going to your monitor. So we already have that. Why create another transistor network with another LCD backlight enable signal to send 3.3 volts to here? That's a waste of 2 transistors. That's the waste of an entire circuit. That's a waste of a signal. Why create another signal and another transistor just to send 3 volts to the part of the circuit that wants 3? It's a waste. We already have it set up so that when you open the computer, when you hit the on button, when you take it out of sleep mode, that LCD backlight enable signal comes on and sends 12 volts through the boost circuit. We already have it set up over here so that it sends power through to the boost circuit when you want there to be a backlight. But it's 12 volts, not 3. So one of the things that we can do is we're going to take that 12 volts. So every single time this opens, and sends 12 volts to the boost circuit, we also want 3 volts to be on the enable pin over here. So what we're going to do is we're going to make a voltage divider. So from up here, and I know this is confusing because there's no line directly from here to here, but see, it's the same thing. It says ppbus underscore SW underscore LCD backlight underscore power there. It says ppbus SW LCD backlight power here. It's the same thing. So what we do is we take a resistor from this high 12 volt power source, and we take that resistor, and that resistor goes to the enable pin. But that will send 12 volts there, right? That's not what we want. So then we send another resistor from the enable pin to ground, and that's going to be a resistor that is a lower resistance than the first resistor. So this is pretty much a voltage divider. What this is simply 2 resistors in series. One resistor between the high voltage source and the output, and another resistor between the output and ground. So to get a very basic little drawing going on here with my paintbrush, this is 12 volts. That's 12 volts. I know, looks like shit. I'm not good at this. Then we draw a resistor, and this is going to be desired output. So this is where we want the voltage to go. This is where we want our whatever output voltage we chose. So we want output here. I'm just going to, I'll spell the whole thing. So that's desired output. And then we take another resistor between our desired output and draw that resistor to ground. Now, remember what I talked about in the ground video. Electricity is very much going to seek ground. It wants ground. It's going to send, if it sees a way to get to ground, it's going to jump through as high as it can. So what we're doing here is, again, we're manipulating it. So we're limiting the amount of electricity that we're going to allow to go to ground with this voltage divider. So we have some of the power going to desired output, but then we have a lot more of that power going to ground. But it has to get to the desired output before it goes to ground. And what you end up with over here is 2.7 or 3 volts or something like that. And I can show you, if you want to see a picture that doesn't look like it was drawn by a 2-year-old, you also have this over here on Wikipedia. So you have voltage in, you have a resistor, you have the voltage output, and then from the voltage output, you go to ground. So the way this works is at this point, at this little black point in the middle, you're going to have a lower voltage. If you really want to get into the math of it, the voltage output is equal to the second resistor divided by the sum of both resistors times the input voltage. And this is not really a complex formula, but I'm really trying to avoid formulas with this. So the whole idea here is a voltage divider is a way that you can create a lower voltage from a higher voltage. Now, the downside of this, let's talk about the downside of a voltage divider. You may be wondering, well, you talked about buck converters and all these other ways with switching transistors and capacitor and filter networks and inductors to make higher voltage to lower voltage. Why are we just not using voltage dividers? This is really, really inefficient because it's always on. It's not switching. It's not like pulsing. It's constantly on, which means that it's always using power. It's always using the maximum amount of power that it's allowed to, and that's really, really inefficient. Now, the reason we don't care here is because we don't need a high current for the enable pin. Again, if the enable pin sees 3 volts, as long as it sees 3 volts, it doesn't matter if that's like a micro. It doesn't matter if it's 1 little milliamp of electricity. It doesn't matter one bit. It can be the smallest current. As long as there's 3 volts there, it's good. That could be using 0.000001 watts, and it's still just fine. So that's why it doesn't matter that this is an inefficient circuit, because it's using such a low amount of current anyway that it doesn't matter. And if you want to get an idea of how much it's using, let's see what the potential is for 12 volts when you have 300 kiloohms. So this is Ohm's law calculator. We're going to put 300 kiloohms and see how much power you can get. So yeah, that's limited to 0.00048 watts. So again, the idea here is we want a very, very cheap way to, once this complex system over here opens, we want a very simple way to simply duplicate what's happening over here to the enable pin. So this transistor is going to open and send 12 volts through to the backlight circuit. We simply want the exact same thing to happen, but we want that to happen on the enable pin every time this opens. And we want a cheap way to get there. Resistors are cheap. They cost virtually nothing, especially when you're buying them in mass manufacturing. So having 2 resistors go to here is a lot easier than having some kind of complex circuit network that's sending PP3V3 from another part of the machine to backlight enable. It's just a lot simpler. PP3V3 would be a 3.3 volt power rail from somewhere else on the computer. So you're going to see voltage dividers in many different points in the circuit, and that is pretty much what they do. That's their purpose. It's to make a higher voltage into a lower voltage. It's when you don't care about efficiency. It's when you just care about it being cheap. And that's about that. It's a very clean way to create the power. You don't have to worry about ripple. You don't have to worry about cleaning out ripple. So let me just give you an idea on this circuit over here, how that works. I'm actually going to show you what it looks like on every single side so you can see it. And you'll also get to see what it looks like in terms of cleanliness of the power that you're creating. See that? So that is the 12 volts. Now that is on this section over here. So on pin 1 of R9731. So what I'm measuring right over here is the power over there that's going into this resistor. Now, let's look and see what it looks like on the other side. On the other side of that resistor, you have .97 volts. And as you can see, it's pretty clean. Now, on the on pin 2 of R9715, which is going to be right over here. Over there, let's see what I got. Exact same thing. And now for ground, which is going to be the other side, I have 0. Okay, well, almost 0. Not exactly 0. It's a little noisy, but it's very simple. It's simply 2 resistors attached in series, 1 resistor between your source voltage and your desired output voltage, which is the lower voltage, and another resistor between your desired output voltage and ground. And if you Google, there are many calculators available online that will help you to calculate the exact voltage that you should expect at that particular point. So let's say you don't know that there's supposed to be 3 volts there. Let's say you're kind of confused as to how this is supposed to work. What I'm going to do now is I'm going to show you how you can look this up without having to be an electronics engineer, without having to be a genius. You can simply use Google. So I'm going to Google, just like I Googled Ohm's law calculator, let's Google voltage divider calculator, right? So here we go, voltage divider calculator. I'm just going to use the first result that shows up on Google, and let's look and see what we're supposed to get here. So over here it says 12.6, right? Over here I see right where this voltage divider starts. It says voltage 12.6, and then where the voltage divider is, it's 301 kiloohms and 100 kiloohms. So we have input voltage of 12.6 volts. Then we have 301 kiloohms, which is going to be 301,000 ohms. And then we have for the second resistor 100 kiloohms, which is 100,000 ohms. And then we hit compute, and it tells me I should have 3.142. I have 2.97. I usually like to say that if the voltage is within 5 or 10%, for most of these circuits, I'm good. And here I'm good. So that's how you can tell if a circuit is working properly. And voltage dividers, again, this is a very, very common thing to go bad on here. So when there's any type of surge on the 12 volt rail, you'll see that right over here at the top of the first resistor of the voltage divider, this will usually be destroyed. And a good thing to do if that's destroyed is to replace both of these resistors. Sometimes the trace will be gone as well, and you'll have to run a wire. But it's good to know what a voltage divider is, because when you look at this, again, when you see this, you're not going to see two squiggly, confusing things anymore. You're going to say, oh, that's a resistor going from a source to a pin on this chip, and then there's another resistor going from a pin on that chip to ground. That's a voltage divider. Why is it there? What does it do? And you'll be able to start asking these questions, and you'll be able to start figuring it out on your own without needing to, buy a new motherboard or be confused or